Set a metering pump to deliver a precise shot of an aggressive fluid, run it around the clock, and a metal one slowly corrodes and wears until the dose it was holding drifts off its set point. The pump shown here keeps that set point. It's wetted heart machined from yttria-stabilized zirconia, sized to return the same measured volume stroke after stroke. Open with hardness above 1,200 on the Vickers scale and a fracture toughness of 8 to 10 megapascal root meter. A pairing that lets the metering element resist wear at the sliding fit while taking the reversing load of every stroke without chipping. Chemical inertness sits beside it. Zirconia holds against acids, alkalis, chlorides, and solvents, and stays out of the fluid it measures. Polished below 1/5 of a micron, the wetted surface carries a thin self-lubricating film and leaves nothing clinging behind, so a measured fluid clears the chamber instead of building up. A dense, dimensionally stable body holds the swept volume it was ground to. The fixed quantity each stroke is meant to move. Accuracy starts with how the pump moves fluid. Each stroke sweeps a fixed volume out of the chamber, so the delivered flow is simply that volume multiplied by the stroke rate. And trimming the stroke length sets the dose, adjustable while the pump runs. The recognized benchmark for that kind of controlled volume pump, API 675, holds steady-state accuracy within 1% of rated flow across a turndown of at least 10 to 1. Holding that figure over years is where the ceramic earns its place. Because the wetted surfaces barely wear and do not corrode, the swept volume and the sliding fit stay put, so the dose that left the bench at better than 0.5% keeps reporting the same set point long after a metal element would have drifted into recalibration. Dimensions follow the dose the line needs. Plunger diameter and stroke length set the swept volume, metered shots that span from a fraction of a milliliter to several hundred per stroke, while the sliding fit is ground to 1/100th of a millimeter and polished to that sub 0.2 micron finish. A turndown of around 10 to 1 lets one size cover a wide band of set points. From there, the build follows the container and the duty. Plunger and bore diameter, stroke, the length of the suction tube reaching into the vessel, the foot at its end, and the inlet and outlet ports are matched to the fluid, the fill, and the head. Each one cut to a drawing rather than a stock size. Where this pump proves out is chemical dosing. The precise, repeatable injection of corrosive treatment chemicals drawn straight from a drum or tank. In a dosing line, the pump lifts chemical up the suction tube, meters a set volume with each stroke, and injects it into the process at a controlled rate. The inert wetted surfaces shrug off the acids and alkalis that pit metering heads. The stable swept volume keeps each shot on its set point as conditions shift, and the non-retaining bore clears between strokes so nothing carries over or builds up. What reaches the process is the dose that was dialed in hour after hour.